In this problem, we're asked to look at NH4HS solid in equilibrium with NH3 gas and H2S gas. The P is 41.2 kilojoules. And for some things we're going to use for later, if you notice that the reactant side is solid, and also that this reaction is endothermic. Before we jump into this problem, a quick definition for Le Chatelier's principle is that any change to a system already in equilibrium will cause a shift to the left or right to counteract the effects of this change until the system is back in equilibrium. Of course, there are some exceptions to this principle, which is basically when there's a change that doesn't affect the shift for equilibrium, as in adding or removing a solid or a catalyst. First, we look at what happens when you add NH4HS solid. So there's a hint right there, is that it says solid. Because adding a solid doesn't affect equilibrium at all, this will have no effect on the equilibrium at all, so it won't shift in either direction. Because this reaction is endothermic, the heat is a reactant. This means that lowering the temperature will shift the equilibrium to the left, which is the reactant side. Now, what happens if you would remove H2S gas? Because this is a gas, it will affect the equilibrium, and as it is a product, removing some will shift the equilibrium to the right to make up for the gas that you took out. And finally, decreasing the volume, which also means increasing the pressure. When you increase the pressure, it will shift to the side with less moles of gas, which, makes sense because it's trying to make it more balanced. And in this example, as you can see, the side with reactants is only a solid, so it obviously has less moles of gas, so it'll shift to the left, which is the reactant side.